Question 19. So again, we're going to do this the same way we've done all the other ones. Find the data, write it down, substitute in. I'm just going to identify the data again. We have this 100 ml of sodium hydroxide, 100 ml of HCl. We have the original temperature, which I've covered over now. We have the final temperature. We have the density, which basically just tells us that because it's 1 gram per centimeter cubed, the volume is going to be the same as the mass. Okay. So the mass in this case is the mass at the end, which is 100 ml plus 100 ml. So it's going to be 200 ml. Now obviously ml is not a mass, but we know that the density equals 1 gram per milliliter. So therefore the mass is equal to 200 grams. We know the temperature change, which is 24.6 increasing to 31.3, which is a temperature difference of 6.7. So substituting in, we get Q equals the mass times specific heat capacity times delta T. So that's going to be 200, keep it in grams I guess, 200 grams times by 4.18 grams per joule per Kelvin multiplied by 6.7. This is going to equal 56,001 joules. Now the question asks you for kilojoules. That's going to be 56 kilojoules. Now the other thing is it's actually asking for the change, and the heat in this case, the water is getting hotter, which means that the heat is being given out by the substance. So the substance is going to have less heat than it had at the beginning. So the actual change is going to be minus 56 kilojoules per mole, because it's a 1 mole to 1 mole reaction. So per mole.